Hey there, out there in YouTube land. We're going to dive right into day 4 of Advent to Code 2021. And I'll admit that these puzzles are already getting difficult, at least for me. And we'll just see how far we can get. I've read over the instructions, and I think I could do the first part, but I have no idea what the second part is. And, well, just cross that bridge when we get there, shall we? Alright, reading off the prompt. Top right, day 4, giant squid. You are already almost 1.5 kilometers, that's almost a mile, below the surface of the ocean, already so deep that you cannot see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo? Bingo is played on a set of boards consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in any row or column of a board are marked, that board wins. Diagonals do not count. Thank goodness. The submarine has a bingo subsystem to help passengers, currently you and a giant squid, to pass the time. It automatically generates a random order in which to draw numbers and a random set of boards. Your puzzle input. For example, these are the numbers that the game master is calling out. So you start with a 7, you look at the boards and see where a 7 appears, and you mark your board. Next, you are 4 is called out, so you see where a 4 appears, and you mark your board, and so forth. And after a while, we will need to look through the boards and see if a row or column has been labeled as a marked number. At this point, the third board wins because it has at least one complete row or column marked numbers. The score of the winning board can now be calculated. Remember that the advent of code folks, they want one number for you to punch in. We start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188, and we multiply by the number that was just called when the board won. So that was 24 in that scenario, and we'll get a final score of 188 times 24 for the example answer. To guarantee victory against the giant squid, figure out which board will win first. And we'll need to type in the final score. So I'll say this again when we get into RStudio, but the way I'm envisioning this is these are 5x5 matrices of numbers, and I'm going to have a stack of matrices. So this will be a 3-dimensional stack of numbers, 5 by 5 by 3 for the example. And then we'll do some work with the order of numbers. So in my directory, Advent of Code, I'm going to day 4 create a space for the example numbers, and I'm going to bring in these numbers that the bingo caller is calling in later. I just want the boards right now. So I foresee myself having difficulty with the spaces in between the 5x5 grids. So I'm going to take the liberty of getting rid of those so I don't have to code them later. Hopefully I'm not hurting myself right now. But now we have these 15 lines of 5 numbers each, and we're going to divide that into 3 matrices. So let's go ahead and open up RStudio. I foresee myself using tidyverse somewhere. Maybe, maybe not. And grab the documentation. Our bingo cards raw information. We will bring in my text file. Gotta save this file too. So now we have our bingo cards raw, our 15 rows of numbers there. Let's see, how do I want to... I want this to be generalizable or extendable to when I bring in the real input. So the number of lines is bingo cards raw, but because I know each bingo board has 5 rows, number of boards is number of lines divided by 5. So we have 3 boards, and I want to make two stacks of matrices. One with the numbers and one with a bunch of true false Boolean values to mark whether a number has been marked or not. So I'm going to make a number matrix. That's the matrix of that's going to be 5 rows times 5 columns. I don't think I've ever made a multi-dimensional matrix before in R. Let me see how to do that. Let me just see if I can do this first. So let's say if M is a matrix with 5 times 5 times, let's say, 3 random numbers, and the number of rows is 5, and the number of columns is also 5. Could this work? Going to run into a snag here. So I'm going to see if I could Google the error. How to stack multiple matrices in R. I mean, literally that's what I Googled. Exciting video stream this time around, isn't it? So maybe the code is not matrix. But what if I had an array? Uh, 5 by 5 by 3. And there we go. So notice in the top right, M is what I want to appear. Okay. So we're creating a numerical matrix using the array function. 5 by 5 times the number of boards. And the dimensions are 5 by 5 rows, 5 columns, and the number of boards. Now I want to also create a Boolean matrix as well. Okay. So now in the top right, we have a Boolean matrix 5 by 5 by the 3 boards for the example, same with the numerical matrix. Now let's see, how do I want to fill this in? For the Boolean matrix, these will all start with false values. And then we want for each line in the puzzle input, we want to, let me actually write that. I should get back in the habit of writing code comments. For each line in puzzle input, we want to place it in the matrix stack. So let's see, for I in 1 through number of lines, these numbers, the function we need is to string extract. We're going to look at the bingo cards and we're going to look for a number. The pattern in regular expressions is that we're looking for a digit, but unfortunately we also have to escape this backslash. So another backslash here. Now the digits, the numbers themselves could be 2 digits long, so we need a plus sign to indicate that we have either 1 or more digits. Now I'm going to skip ahead and note that string extract finds the first number in a row or in a string. Since we're going to be finding 5 numbers at a time, I'm going to go with string extract all. Now it will find the numbers, but then return strings. So finally we need to convert to numbers. So for the first row, I want it to be in the first row of the first board, but what I'm worried about is once we get to the 6th row, how do we tell that to go to the next board? There's a complication that comes up when you're working with R and modular arithmetic, that since R starts counting at 1, but modular arithmetic, the remainders when you divide could be 0, you have to make an adjustment, or at least to the best of my knowledge. So the row number is I mod 5, but if row number becomes 0, I want the row number to go back to 5. So now, in the numerical matrix, at that, and also have to take care of board number. Board number is going to be I integer division 5. But again, because R starts counting out 1, go ahead and make an adjustment there. So we got row number, column blank, board number. And hopefully that works. Nope. In string extract all returns a list of characters, so I forgot to unlist it. Subscript out of bounds. I forgot to look at only one row at a time in the puzzle input. These are the frustrating let's see if the numerical matrix has been filled in a little bit. Nope. That should be out of bounds. Okay. Well, I'm going to dive in and see what my for loop is really doing just to make sure of everything. Make sure these numbers are indeed the first row of bingo cards. Okay. Then the row number is 1. The board number is 1. Did I not even tell R to fill in anything? So that's something. But will this line of code work now? Numeric matrix, first row, all columns, first board, these numbers. So now numeric matrix, the first board should look like that. The second board should still be empty, and the third board should still be empty. Okay. Why am I running into an error? Trying to figure out where. So I'm getting to the last row of numbers, what I suspect. These are 15 rows, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I don't think I have an issue there. I is 15. in the numerical matrix, if I have the 5th row, all columns, 3rd board, that should get a number. But it's also getting the wrong numbers. So let's see if we could track this down. So again, what I'm trying to do is get these numbers in a 5x5x3 matrix in R. And I built some for loops to do that. Numerical matrix, the first board. Ooh. It's skipping a row. The second board. Yeah, it's not handling the... What happened here? And the third board. So somehow, this is the last row, but it's supposed to be in the first matrix. This is a last row, but it's supposed to be in the second matrix. A little frustrating, but hopefully something we can easily fix. And I think it's here. If we're in a multiple of 5, the board number is this. Else, the board number is that. No errors. And let's double check our matrices again. All rows, all columns, first matrix. All rows, all columns, second matrix. All rows, all columns, third matrix. And let me bask in my ability to copy and paste numbers. So now, let me just create something on the side. I just want to see where the numerical matrix is equal to the number 7. The first number up here that the play caller is going to make. So what I should have is Q is also a matrix. All rows, all columns, first matrix, where it's mostly false except where the 7 appeared. Like so. Okay. So now, notice that I didn't bring in the other numbers yet, so numbers called, I'm going to do this manually. let's let capital N be the lengths of numbers called. So what will happen is the Boolean aspect of putting a bunch of true and falses when the number is called. I think I have that in almost ready to go. Trying to realize the actual checking of rows and columns. That's what I'm worried about. This is actually the amount of numbers called. In play will be the numbers called from 1 to amount numbers called. And the Boole matrix is simply the numerical matrix who has values in play. So I want to restrict this to 2 numbers for now, just see if this works. So in play were the numbers 7 and 4. And what we're trying to get are these highlighted numbers here. Oops. That's after 6 numbers. Maybe push this up to 5 numbers to match the example. So now my Boole matrix, all rows, all columns, 1. Ooh, that's not good. So for some reason my Boolean matrix did not maintain the 3-dimensional stack of everything. So I'm going to do the inefficient thing and make 3 for loops. So my Boolean matrix, I want 5 by 5 by 3. For I in 1 through 5, for j in 1 through 5, for k in 1 through number of boards, Boolean matrix I, j, k is if the numerical matrix I, j, k is a number in play. Okay. now, Boolean matrix, all columns, all rows, first one. A little hard to see, but I think everything's lining up correctly. I wonder if I could just do now numerical matrix at Boolean matrix. Almost. Okay, so making the boards, I believe, is done. Checking the boards for the numbers that are called, I believe, is done. And now we have the aspect of checking the rows and numbers. So I want to go down through all the rows, all the columns in each board. So for example, in rows 1 through 5, if that row, if the Boolean matrix at that row, all columns, at that board number, if the sum of if the amount of times the word true appears is 5, then that's when I want to essentially print bingo. I want to retain the row number. So we're going to create a flag that tells that we have at this point finished the game. Because if I only do the break statement, it's only going to break free the first for loop. I gotta do this. Print row number and print the board number. Similarly, this is to check rows. Similarly, to check the columns. I want to also put the break statement there. To check the columns, we look at J, column J, Now, I'm calling the first 5 numbers. This shouldn't do anything, according to the example, but if I call the first 6 numbers, that shouldn't do anything. Was it the 7th number? No, it said all the way until 24 is drawn. So let's just go ahead and push this all the way through then. All the way to N. Bingo on row number 1 of board number 3. Look at that. I'm doing okay. I just wish it didn't take me 36 minutes to get here. So then the score will I think what I want to do is just restrict ourselves just to the 1 bingo board to make this calculation easier. So we have the winning board numbers. That's going to be the numerical matrix at the winning board. Winning board Boolean, that will be the Boolean matrix at the winning board. What is it? Uncalled numbers. It's going to be the sum of the winning board numbers at the winning board Boolean, but actually I want the false values. Last called number is the num called at the amount numbers called, and then finally print that the score is the uncalled numbers times the last called number. And we're going to get the 4512. Look at that. Okay, we'll see if this now works on the puzzle input. So, going to create a text document. For my puzzle input, just the boards. Now, what I should have done is figure out a way to code this where I dealt with the empty spaces, but you're gonna, if you're actually watching, you're gonna watch me do this manually. If I had some video editing skills, I would probably speed this part up and throw in some music. this is a lot more in terms of number of boards than I thought. I'm actually wondering about runtime now. I admit that the program I wrote is quite inefficient. So if we have something like 100 boards here, would my computer be able to handle this and also do calculations within, say, 5 minutes? And making sure I don't have an end line there. So now the bingo cards are going to come from the new input file, and the numbers called here. Actually, probably. Oh, there are a lot of numbers. There we go. So we're gonna build the matrices. The number of boards, yeah, is 100. Then I'm gonna play the game. We got bingo on row number 5 of board number 64. And the score of that, we're right. Let's give ourselves a nice pat on the back. That was quite a journey. 45 minutes for a novice like me to solve part 1. Part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once, so rather than waste time counting its arms, the safe thing to do is figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. If I'm reading this correctly, I think all I have to do is just not break the loop. Is that right? So this time around, I think that's true. All I have to do is just not break the loop. The loop. And then I just go all the way to the end, and hopefully we'll get a result. I'm going to time this because I'm curious how long it will take my computer to solve this. And to be honest, this might take 5 minutes or so, which is just excellent use of video production. Well, it took 0.35 seconds, and that's not the right answer. Darn it. Did I also forget to comment out the columns? Look at it go! And it took 3 seconds, but the final score is 0. Maybe I could just grab the last one here. How would I do this? So we need column number 4 and board number 1. But if almost all the boards are called, wouldn't the final score be very small? And also, it looks like board number 1 is the last to win anyways. So why don't we do that? If board number 1 is the last to win, we need to change these still. So if it's board number 1, then the game is finished. Still not the right answer. So what I'm looking at is 68 of these numbers are called out of the 100. Once we get to literally number 62 here, then the process went. So the winning board numbers were the first board in the puzzle input, actually. Winning board Boolean has the first column here. Uncalled numbers, adding up the location of where these were false. Last called number was the 62. And yeah. Maybe I didn't correctly figure out which board was the last to win. Does that make sense? So there were 100 boards. And I just assumed board 1 was the last to win because that's what was at the end of my output. But what if instead I want to create a board tracker for the number of boards. And then so whenever a bingo is found, I want to, in the board tracker, at that board number, make that true. And then if the sum of board tracker is equal to the number of boards, that's when we break the game. Nope. Number of boards is 100. Board tracker has 100 elements in it. Why is my board tracker stopping early? Why is my number of boards is 100. Summer board tracker is 33. Try one more strategy and then we'll call it a night. So I have my board tracker. My guess is right now that not all 100 boards will win. That's what's happening. And what I want is if board tracker .k is false, then do all this. Same thing here. If board tracker is false. looking at board number 14. Somehow I really lost track of all the braces. That's what's really stinks right now, because I was being very careless. So what I want to do is going through all the boards then check the rows. And then check the columns. make a variable for the last board called. But what? Because some boards could win multiple times later on. That's the issue. What if I just did that? What if I just did winning board? Winning board is I'm going to keep track of who won each time. Now, winning board. Why is it not keeping track of anything? What if I just let go of that statement? So winning board, if you see here in the top right, winning board announced, yelled out bingo over 7,000 times. So what I want next is unique winning board. I still think the winning board's 14. The last winning board's 14. So I think I could still salvage this. If K is 14, game's finished. if anybody's actually going to watch this video and skip to the end of this 1 hour and 15 minutes, but at least I did it. And we'll be off to puzzle day number 5 tomorrow. See ya.